All right, good morning and welcome back. Go ahead and turn in your notes to page 6.4. Just a reminder that today is our last lesson for the week. Then tomorrow there is a quiz. Okay, so make sure we get that done. Should not be very long, just kind of check up, keep you guys accountable for this week. So if you have any questions over this or tomorrow on the quiz, please let me know. Reach out. So, what we're talking about today, we're continuing to talk about the unit circle, but we're talking about those situations where the degrees are higher than 360 or maybe more than 2 pi, okay, if we're talking in radians. So, what we mean, degrees over 360, okay? So, for example here, sine of 405 degrees. Now, we're used to when we have it, we go on there, we look, 405, we trace around, and we don't find it, right? Because it's from 0 to 360. Now, what we can do, all we have to do is subtract 360 away from this 405, and we'll find an equivalent value. So sine of 405 degrees, if I subtract 360 from 405, I'm left with 45 degrees. So then the sine of 45 degrees, the reason we can do this, if you think about it, the sine of 45 degrees is right over here. It's the y, so square root of 2 over 2. Now, 405 would be go around 360, and then we start again, 45 more, gets us to that same spot. So if you think about it, we could go around this as many times as we wanted, and the values are still equivalent, okay? So if we subtract 360 from whatever we have, then we're left with 45, so we know square root of 2 over 2 will be our answer. So my final answer, square root of 2 over 2. Now this next one, tangent of 840, same thing, 840, we'll subtract 360 from that. Okay, now when we subtract 360 from 840, we'll be left with a tangent of 480. And hopefully you realize that didn't get us where we wanted to go. We're still greater than 360, but that's okay. We just do it again. So we'll just subtract 360 again. We're left with tangent of 120 degrees. Okay, so now from here, we go to our chart. So if it's 840, essentially we go around 360, and another 360, that would give us to 720, and we'd still have 120 more, which would get us here. Now when you're doing it, you don't need to trace your pencil around 2 times first. You just can go right to 120. It's always going to be equivalent to that value. Okay, it's like it went around twice, but it's equivalent to this. Okay, so we are looking for the tangent of 120, which up here we've already marked on there. If you didn't have it marked there, you could find it by doing y divided by x, but we already have it, so negative square root of 3. All right, now our final example up here is dealing with radians instead. So what if it's radians over 2 pi? Same thing. Oops, I forgot up here to put subtract 360. Right, so we always subtract basically like one circle. So one circle is 360. If we're in radians instead of 360 degrees, it's going to be 2 pi radians is equivalent to one circle. So we'll subtract 2 pi radians from it. Now, some of you might be wondering, well, how do I know if it's bigger than 2 pi? Okay, so if we look here, cosine of 11 pi over 4. A good way to check real quick, the denominator is 4, times that by 2, that's 8. 11 is more than 8, so we know it's more than 2 pi. So if we think about it now, we're going to subtract 2 pi. Now 2 pi, it's a fraction, so I'm going to put it over 1. But in order to make this easier, you could reason through this in your head, but the easiest way is to find a common denominator when you're doing subtraction. So we have 1 and 4, so the good choice is 4. I'm going to multiply this by 4 over 4. Because if I multiply it by 4 over 4, that's the same as 1. I'm not actually changing it, I'm just changing how it looks. Now if we do that, we're going to get negative 8 pi over 4. So from here, if I had the 11 pi over 4, and I subtract 8 pi, I'm going to be left with 3 pi over 4 as my answer. So I go ahead and just put cosine of 3 pi over 4, and we'll see what we get. So we go back to our chart. Cosine is our x. We go to 3 pi over 4. So we can trace around to 3 pi over 4 here. And the cosine right here, negative square root of 2 over 2. All right, so now the next thing we want to talk about, and we briefly mentioned this last week. Okay, we did. Some of you, this is going to be easy. What if we have negative degrees in radians? Okay, so all of these, same thing. We're trying to find the value, what represents it on the unit circle, but this time it's negative. Okay, so last week we talked about this, and we know that negative means it's going clockwise. So negative 210. It's totally up to you how you do this. If you want, you can come here. We know negative 180 would get us to here. 30 more, that would put us right here at the 150. That works. That takes a little bit of reasoning. An easier method might just be to add 360 if it's with degrees, or you can add 2 pi when you're dealing with radians. And I'll show what I mean by this. So if I say add 360, negative 210, let's do plus 360. Then we'll find the cosine of 150. So I guess I don't actually need those parentheses since it's positive now. So cosine of 150 degrees. And as we said, we went minus 210. So if we start here, minus 180 and then minus another 30. Or since we added 360, we got 150, which is that same spot. Okay, so that might be an easier method than kind of reasoning through it here. You can just always add 360, and that'll get you that. Now, if we didn't add enough, we would maybe have to add 360 another time. So just do it until it becomes positive. So right here, we're finding the cosine. So at 150, the cosine, the x value, negative square root of 3 over 2. And we are done. Next one, same thing. Plus 360. It's going to give me the sine of 45 degrees. I keep doing that. I keep putting that parenthesis. I don't need it. Okay, the sine of 45 degrees. Now, once again, if you are having trouble doing this in your head, that's fine. Pull on a calculator. Negative 315 plus 360, or you could even do 360 minus 315. Either way will get you 45. Okay, so we go over here. Sine of 45. 45 is right here. Sine is square root of 2 over 2. Now, the final one, when we're dealing with radians, it's maybe a little more difficult because of the fractions, okay, that are often present with radians. But on this next one, we're going to add 2 pi. So think about that, plus 2 pi, just like we did up above when we subtracted. This is over 1. I want a common denominator. So this time, instead of 4, as you can see up above, our denominator was 4 on the original, so we use 4 over 4. Here our denominator is 6, so I'm going to use 6 over 6. I'll get 12 pi over 6. Okay, so now 12 pi over 6 minus this 5 pi over 6, we're going to be left with the tangent of 7 pi over 6. We can figure out what that equals pretty easily. We go to tangent 7 pi over 6, right over here, square root of 3 over 3. And that's all there is to it. So now, flip to the back. We're just about done. One more concept we want to talk about today, and that is, what do we do if there's more than one trig function present? Okay, so it's not that much harder. It's kind of like two problems put together, and then we do the algebra behind it. Okay, so right here, the first thing we need to do is decide what the sine of 60 is and what the cosine of 330 is, and then they're right next to each other. We'll multiply them. So sine of 60. Go over here to 60. Sine is y, so square root of 3 over 2. Then we're going to multiply that with whatever the cosine of 330 is. So we go to 330. Cosine is square root of 3 over 2 as well. So we multiply across the top, across the bottom. Square root of 3 times square root of 3, you guys hopefully know, is 3. Or you can think of that, remember, square root of 9, which gives us 3. Okay, 2 times 2 is 4, so our answer is 3/4 here. Now the next one, cosine of negative 90 minus 3 times the sine of pi over 2. So this one has a little bit more going on. First off, there's degrees and radians. There's a number out front. We're subtracting. A little more complicated. This one's negative. The fact that it's degrees and radians shouldn't affect us. We can just find both of those numbers and then combine them. So let's start off negative 90 degrees. Let's take care of that. So let's add 360 here. And we're going to be left with the cosine. Let me do this in a different color. The cosine of 270 degrees minus 3 times whatever the sine is at pi over 2. Okay, so now cosine of 270. So we go to our unit circle. 270 down here. Cosine is the x. That says 0. So we get 0 minus 3 times whatever sine of pi over 2 is. So we go to sine of pi over 2. Pi over 2 is up here. Sine is 1. Okay, so 3 times 1. Now, order of operations does matter. Okay, on this one, it would give us the same thing either way, but we got to take care of our multiplication. So 3 times 1 is 3. 0 minus 3. And that will give us negative 3 as our answer. Okay? So remember, order of operations, PEMDAS, or please excuse my dear Aunt Sally, depending on how you learned it, parentheses, exponents, multiplication, division, addition, subtraction. Okay? So our final one now. Same approach. Okay? This time, though, we have a secant. Okay, so when we get that, to find our secant, we'll have to take a reciprocal. But we're not quite there yet. Let's first deal with this negative. So negative 3 pi over 4. Once again, we're going to want to add 2 pi, which we know is over 1. So we check our denominator. It's 4. So 4 over 4. And if one way to think about it is we always want to get it into that sweet spot between 0 and 2 pi or 0 and 360. So if it's bigger than that, you subtract 360 or 2 pi. If it's smaller than that, you add 360 or 2 pi to get it into this sweet spot. Now, we multiplied by 4 over 4. We're going to get 8 pi over 4. Okay? So 8 pi over 4, if we add that up here, 8 pi over 4 minus 3 pi over 4, put that together, and we're left with secant of whatever 5 pi over 4 is. So the reason I know that, 8 minus 3 gives us 5, so 5 pi over 4. Okay, now, we're going to, whatever we get there, we're going to add with the tangent of pi. Now, before we find the secant of 5 pi over 4, since that's a reciprocal, I want us first to think secant pairs up with, and hopefully remember, cosine. So first, let's find over here the cosine of 5 pi over 4. What is the cosine of 5 pi over 4? So we go back, cosine of 5 pi over 4. Down here, cosine is negative square root of 2 over 2. So negative square root of 2 over 2. So we're going to take the reciprocal of that. So I come over here to the secant 5 pi over 4. Secant of 5 pi over 4 is the reciprocal of this one, which will be 2 over negative square root of 2. Or if you prefer, I know some people don't like to have that negative on the bottom, so we can think of that as up there. It doesn't really matter. Okay, plus, now I know we can't leave it like that, but let's figure out what's over here first before we deal with the square root of 2. Okay, so plus, let's go tangent of pi. We go to pi over here. The tangent of pi is 0. So plus 0. Okay, now from here, what we can do, we can rewrite this. The 0 doesn't matter, so minus 2 over square root of 2. All we need to do now is multiply by square root of 2 over square root of 2 to rationalize that denominator. Go across, minus 2 square root of 2 over 2. Okay, now from here, we need to cancel out these 2's. We can't deal with what's in the square root, okay? So our final answer, we just get negative square root of 2. All right, so that's all there is. Make sure we get the quiz done, and if you have any questions, please reach out. Have a great day.